Hello. Hi, sir. My name is P. Ganesh. Today, I have selected top problems statement based on regression methods with machine learning, and in the subtopic is decision tree and tree ensemble. Introduction about the topic which I have selected from the Excel machine learning course. First introduction about the subtopic is decision tree and tree ensemble. I have selected subtopic. Introduction is decision trees are among the most interpretable and simple to implement machine learning algorithms applied to both classification and regression problems. And they work by recursively the data set into smaller subset according to future values to construct a tree-like model. A key hyperparameter in decision trees is minimized to leaf size, which determines the minimum number of observations at the leaf node. Models such as fine trees and coarse trees differ to terms of granularity depending on minimum size leaf size. Fine trees employ small leaf size to allow for precise splits, where various coarse trees utilize larger leaf size to enforcement generalization. Problem statement which we have cited from the decision tree and tree ensemble. First, to examine how varying minimum leaf size setting of decision tree impact that the accuracy and generalization ability of model. We experiment with the behavior of a fine tree. Minimum leaf size is equal to 4. Compared to the coarse tree, a minimum leaf size equal to 36. To reveal of more trade-off between overfitting and reliability. They work by splitting the dataset based on futures values to form a tree-like structure of decisions. One of the key factors that control the complexity of a decision tree is the minimum leaf size. This is the minimum number of samples required to create a leaf node. Why is minimum leaf size important? A small minimum leaf size like 4 results in a fine tree. This allows the tree to split the data into many small groups, capturing very fine patterns in the training data. As a result, a fine tree usually has high accuracy on training data, but this comes at the cost. It may also learn noise and specific details that do not generalize well to unseen data, a problem called overfitting. On the hand, a large minimum leaf size like 36 produces a coarse tree. This tree is shall over and simplifier because it requires more data in each leaf. While this might reduce training accuracy, it usually improves the model ability to generalize to new data, making it more robust and less likely to overfit. In practical terms, the fine tree is good when we want high accuracy and we are okay with the risk of overfitting, especially on clean and simple data sets. The coarse tree is useful when we need model that easier to interrupt, run faster, and handles noise or real world data better. So in this project, we compare a fine tree with minimum leaf size 4 and a coarse tree with leaf size 36. Using the iris dataset to see how the hyperparameter affects and balance between complexity, accuracy, and generalization. Next, dataset and pre-processing. We apply the iris dataset to the project, which is popular benchmark dataset in the machine learning and pattern recognition domain. It includes 150 samples of iris flowers from three varieties: Setosa, Veriscolor, and Virginia. There are four numeric features in each sample that present the physical measurements of the flowers. There are sepal length, sepal width, and petal length and petal width. These attributes are continuous and range from different values, so the data set is suitable for testing classification models such as decision trees. The target variables is the flower species, which is categorical variable with three classifications. In MATLAB, this dataset is readily available using the fish iris dataset, which is loaded into two variables. Means measurements are a 150 into 4 numeric matrix of features, species, 150 into 1 cell array of strings of the class labels, and pre-processing steps. Prior to training our decision tree models, we must pre-process the dataset using the following pre-processing steps. Loading the data. We load the future matrix X, means and target vector Y is equal to special using the inbuilt load freshers comment. Data inspection. We check for missing values or inconsistency in the data. The iris data, we do not have missing values or categorical features in future space, and hence imputation or encoding isn't necessary. Format of labels. The class labels are already given in the form of categorical strings, which can be directly handled by MATLAB fit text trees function. Data splitting. And for accessing the model's performance reasonably, we partition the dataset into training the text subsets. 70% for model training and 30% for performance testing. This is performed with MATLAB CV partition function to provide a randomized and representative split. No future scaling necessary. Unlike certain algorithms, examples like KNN or SVM, KNN means K nearest neighbor or SVM means support vector machine. There is no need for future scaling or normalization since decision trees are threshold based splits rather than distance based computations. Through the execution of these pre-processing steps, we guarantee the data is clean, approximately labeled, and ready to input into fine tree or posting. In this, we conclude that data inspection and pre-processing steps of there are four measurements like sepal length, sepal width, length, and partial width are used petal width are used. Pre-processing steps and data inspection, format labels, data splitting are known. Uh, we all conclude now. We conclude that fine tree and coarse tree are two models for evaluating and training. Model building and implementation. Once the data set is pre-processed and split into training and testing sets, the next step is to build and train the models in this project. We are comparing two types of decision tree classifier, fine tree and coarse tree. First one is fine tree or second one is coarse tree. Fine tree, first one. This uses a minimum leaf size of 4, which allows the tree to grow deeper with more branches. This increases model complexity and ability to learn fine details from data. Cost. This uses a minimum leaf size of 36 and resulting in a simplifier and slower way. This generalizes better and reduces the risk of overfitting but more subtle pattern. Use MATLAB fit tree function to train these models. This function fits a decision tree for classification using the classification and regression tree. This COT algorithm. First, we have created a new script or new folder for the MATLAB. We have implementing the code. Here, load feature is the loads the iris dataset which contains 150 sample of iris followers. Means 150 into 4 matrix containing future values like sepal length, sepal width, petal length, and petal width. Species are 150 into 1 cell array of species labels like Setosa, Versicolor, Virginia. X means assign the future matrix to X. Y species means assigning label to the Y. Next. Here, C partition creates a partition object that splits 30% of data for testing, hold out equal to 0.3 and 70% for training. CV training CV logical index vector for training samples, test CV logical index vector for testing samples, Xtrain or Y-train. Training data sets are labels. Xtest and Y-test are testing data and data labels. Next. Here, fictitious tree trains a classification decision tree, min leaf size. Control the minimum number of observations per leaf node. Fine tree, minimum leaf size equal to 4. Allows the tree to split more often. Deeper tree. Coarse tree, minimum leaf tree equal to 36. Favor split allowed and solve for and simplified tree. Here predicts the classes labels using the trained model. Strong compare predict and actual labels returns logical vector. Some num y test is here some num y text theory uh, calculates accuracy as a ratio of correct predictions. F printf displays the accuracy in the percentage format. Here, confusion chart displays a confusion matrix for actual versus predictor labels, helps visual access how well each class was predicted. Next, next is evaluation and result. Next, we have to run the code. What we are we have to save this. This code is running. It's giving the result in terms of fine tree accuracy and coarse tree accuracy. Here, here the coarse tree confusion matrix of Setosa, Worklosa, and Virginia. It is true classes and Setosa work. This Virginia vesicle is a predicted class. Next, here is the figure one fine tree confusion matrix was true close and predicted values. First here we had two significant results accuracy and coarse tree accuracy. Fine tree accuracy the fine tree accuracy perform better in terms of accuracy on the test based data. This is due to the fact that a fine tree with a small minimum leaf size of 4 is able to capture very fine patterns in training set. Coarse tree accuracy. The coarse tree was slightly less accurate than the fine tree because it applies higher minimum leaf size and model is less complex and misses very small pattern. The accuracies were printed in F print and usually display something like metamedia copy code. Free tree accuracy is 95.56 and coarse tree accuracy is 66.67. Confusion matrix. We compared the performance. We confusion matrix. We compared the performance of two models visually using confusion chart. Next, fine tree confusion matrix demonstrate that the majority of the test samples were classified correctly. Few misclassifications occurred. This means that their fine tree is extremely accurate on test set. Coarse tree coarse tree confusion matrix. Also performed well, but this more errors than the fine tree. Some species may be mistaken for one another. Next, next conclusion. In this project, we examined how the minimum leaf size hyperparameter affects decision tree models in relation to comparing a fine tree. Minimum leaf size equal to 4 and coarse tree minimum leaf size equal to 36. Utilizing it is data. The finding indicated that the fine tree had greater test accuracy, indicating that it can learn to pick up the subtitle patterns in the data. At the same time, because it is complex, it would be more adaptable to overfit when working with noisy or new data. Conversely, the course tree, although less precise, offered a more basic and generalized model. It minimized the risk of overfitting and had a good balance between bias and variance. In general, whether to use a fine tree or a coarse tree is to application specific. It is the highest accuracy and familiar data is desired when a fine tree is best. If a crucial to build a strong and general model, a coarse tree would be a more suitable opinion. With comparing with the coarse tree or coasty or fine tree. Coasty is better to use or coasty would be more suitable option compared to the fine tree. This concept undergoes significant choosing model hyperparameter and becomes actual problem.